Hello and welcome to my English YouTube channel, here with a part that I modeled a few days ago in my German channel Flowie's Corner. It's a pipe with a slotted hole that you see here in the lateral surface of the pipe or of the cylinder that has two drillings here and here, who are both perpendicular to the surface of the pipe, and between the two holes we have a milling path here. And I tried to model this whole piece parametric so that I can change a few parameters, like here in the polar pattern I can change the angle of my slotted hole maybe to a 30 degrees, and as you can see, automatically the hole gets a little bit smaller, and you can even go a lot bigger to maybe 180 degrees. And now the slotted hole goes around half of the whole pipe. I have a few other expressions here in my file. Like in this sketch, I can change the length of my whole pipe. I can change its inner radius here. And no matter what I do, my slotted hole will always follow. We will always have a nice clean slotted hole through all the pipe. And yes, you might be interested how to model this. You should have at least a little bit experience in FreeCAD, so it's not a tutorial for the complete beginners. So you should have a little bit of experience in part design and how to work with expressions here in FreeCAD. I would say let's start a new file and start the tutorial. Have fun. So here I'm in FreeCAD. I started a new file and I will show you the version of FreeCAD that I'm using. I'm using revision number 21049 from the Git repository from the 12th of May in 2020 on a Windows 10 machine, 64-bit. So, okay, let's start it. We start using a new body, and within this body we have an origin that contains the planes that we will use to draw on. So I will make it visible pressing the space bar. And the first thing I want to do is I want to start with my pipe. So I go to the XZ plane here and say new sketch. So I'm sketching on the XZ plane and start with a simple rectangle that I click twice. And now I have to make it rest here on the y-axis, on the vertical sketch axis. I have to define the thickness of my wall here. That's 2 millimeters, and I give it a name. Let's say WT for wall thickness. Let's define the inner radius with the vertical distance from here to here to, let's say, 10 millimeters. IR for inner radius. I will have to remember all those abbreviations that I do. So, and the next thing is the pipe length that I will define with a horizontal dimension here too, maybe like we had in the example before, 50 millimeters, and I will just call it pipe L, pipe L. Yes, okie dokie, and we're good. So we can close the sketch now and rotate it around the global x-axis or around the horizontal sketch axis, which will give the exact same result. So we will take the sketch and go here to a revolve. Now we have standard the vertical sketch axis, which is not correct. We can, as I just mentioned, use the horizontal sketch axis or the base x-axis, which will have the same result. 360 degrees, that's correct. So, okay. the next thing that I need is I need a datum plane that rests here on the lateral surface of my cylinder, and I don't want to glue it on the surface here because we all know the so-called topological naming problem, so I avoid gluing my objects on real 3D surfaces. So I will use a new datum plane here that I will define relative to my XY plane here. And in Z direction, I need to shift it up to 12 millimeters. So I'm outside. The only problem now is when I change my pipe and I make it bigger or smaller, this will rest on a distance of 12 millimeters fixed from the XY plane, which is not correct. So I have to make this one here also variable using the expressions here. So I go on this expression icon here, and then I can define it using expressions. So I know that the distance from the XY plane has to be something like from my sketch, a constraints dot, I called it IR for inner radius, plus, let's copy this, sketch constraints, copy and paste, sketch constraints dot WT for wall thickness, because we have to add the inner radius plus the wall thickness. If I defined in my sketch the outer radius, I would not have to do this mathematical operation. I could just say always the outer radius is the correct value. But in this case, I think I'm good. Here it turns light gray, so I see it's no longer a fixed value but a variable. So okay, and let's test it before we continue. That's something that I really got used to, always test the small steps so that I don't get surprised in the end that everything is falling apart because I made somewhere on my path some mistakes. And so I will check this one and go for the constraints in my sketch and change the inner radius to 15 millimeter, for example, or 25 millimeters. And as you can see, the plane will always follow. So that's correct. I have a plane that's not glued on a surface like this one here, but is always following the outer radius of my pipe. That's exactly what I was planning to do. So I can change it back to the original values here, 2 and 10 millimeters, and then I can continue. Okay, the next thing I want to make is the drilling on top of this datum plane. So I select the datum plane and go for a new sketch. I create it as a simple circle here, somewhere around here. Does not have to be correct yet, because I will use a line that I define as a construction geometry. So I switch with the button here to the construction mode. My icons here turn blue, and I will start a new line. Starting here, I catch the center point of my sketch, and then I catch the center point of my circle. And now I will select the line here and say this line always has to be horizontal, like this one. Okay. Yeah, the next thing, I need a drill diameter here. So I will switch here to constraint diameter, select the circle, and let's say 4 millimeters, and Datum, whatever. Just that I always have to remember how stupid my variable names are. Maybe you know how to give better variable names. That's just what I'm doing. So I have 3 constraints. What's going on here? The point here, as you see, was not fixed on my center point of the sketch, which is pretty stupid, but we can fix it. We just select the 2 points here, and say make them coincident. And now I fixed it. Only value that I'm missing is the distance from the start here. I give a horizontal distance 40 millimeters and I'm good. I can close it. So the next thing we have to do is we have to drill a hole with this sketch. So we select the sketch and go for make a pocket, create a pocket. That goes to first. So we only drill through the first wall of our pipe and say, okay, we can hide the plane, selecting it and pressing the space bar. And now we already have a nice hole drilled in on top of our pipe. That's already variable here, and we can control it using our constraints here on the left side and the property manager. So that's a good first step, I would say. The next thing, we need our polar pattern to create another hole. I always imagine this as this is the first hole where you go in with your drill, and then you move your drill along the lateral surface of your cylinder, and the second hole is where the drill is leaving my pipe. So I will select this pocket here, and then I will create a polar pattern feature. So this pocket, okay. Yeah, we have another stupid reports and mistakes down here because we have not yet selected the correct axis and so on. And so the first thing we need to do is we have to select reference, and we want to revolve around this x-axis here and not 360 degrees, but only, let's say, 45 degrees for testing purposes. 2 occurrences, that's correct. First occurrence is always the original. The second one is this second hole here. Okay, that's okay. So we already have the 2 holes. Now we only need the surface or the milling track between the 2 holes, and this is also very easy to achieve. We just make our origin visible here, clicking the space bar, and then we select the XZ plane again and make a new sketch. And within this new sketch, we don't want this geometry to be in front of our sketching path. So we can click this nice button here, switches between section and full view. We click this one, and now we have a nice section view of our pipe. We start with a rectangle as well here. And our rectangle here has to have a horizontal distance here. That's not defined here, but this was defined before in our sketch 001. If I had given a good name for it, like a better label, I would not have to select it here, but whatever, I will do it like that. So constraints dot Datum was the name of it. Yes, okay. So this references to Datum that I made in the other sketch. The vertical distance from the bottom of my rectangle has to be also defined in another sketch. It was sketch without a number, and it was the constraint IR as far as I remember. Yes, this is IR, very nice. And yeah, that's good. And the height of my rectangle here is the wall thickness. So another vertical distance here that has also been press the equal sign on the keyboard or press this button here, gives the same result. This was also defined in sketch, and its name was, let me think, WT as far as I remember, wall thickness. Yeah, that's good. Okay, so the only thing that's not correctly defined yet is the distance, the horizontal distance from this point here. So I will hard code it for now, but I will change this later doing a simple mathematical operation. So at first, this is enough for me, just say 38 millimeters, and that's good. So, okay, I can hide my origin and start doing with my sketch 2, doing another groove. The groove goes around. Let's select the reference again, the x-axis here, not 360 degrees, because in this case we will lose our pipe. We don't want this to happen. So we could say 45 millimeters, but if we change the polar pattern, then this would not follow. So we also have to define it here as an expression, and we just have to say polar pattern dot angle. So the angle of my groove here will always follow the angle of my polar pattern. Okay, so now I'm already pretty far. I'm not yet done with everything, but if I change my polar pattern angle here, as you see, this will follow. So pretty good as far. But I just told you that I have one little mistake in my construction, and the little mistake comes from not from this sketch, but from sketch 001 here, where I defined the 40 millimeters to be fixed, as I defined the 38 millimeters here to be fixed as well. And if I change one of those two, then I will have a different distance for my drill than for my groove here, and then I will get an error. So I might even test it just to show what I mean. I could just change this to, let's say, 42, just for presentation. And as you see, now I have the drills and the groove here no longer aligned correctly. So that was just what I wanted to tell you. I have to find a way to make this one here correct. So first thing I need to do is I have to give these 40 millimeters also a name, and I call it DD for drilling distance, which is pretty stupid as well, but please be patient with me. I'm not English native speakers, and so I always get messed up with finding proper variable names in German already, and so when I do this in English I'm completely lost. So let's call it just DD, because I need to reference this one here in my groove sketch. Okay, the 38 millimeters cannot no longer stay 38 millimeters. I have to make them variable as an expression here. Press the expression command and just say sketch 001 constraints dot dd minus, and now I have to make a calculation. It is the 0.5, so half of my sketch 001 constraints diam. So this is my diameter of my drilling, and I need to take half of it, so I have to add half of it to my I have to subtract half of the drilling diameter to find the correct position of my sketch here. So 38 millimeters, that's correct. So you see this sketch here, it is, I think this is sketch 2, is completely controlled by other sketches and other expressions. So I can hide it, and now I can try it again and change the length here of my first sketch, let's say 45 millimeters, and now the whole slotted hole should change its position. Correct. Yeah, that's what I wanted to do. And whatever I change now, let's say the diameter of, or the inner radius. Oh, 158 was maybe a little bit too big. Pipe L and wall thickness, maybe make it a really thick wall, 8 millimeters, but still my slotted hole will go through the whole pipe. Okay, that's what I wanted to achieve. I know you could improve this tutorial a little bit, I guess, but I hope my English speaking friends are happy with the English version of the tutorial. And so that's it. Goodbye.